Today we are going to learn about the slope of a line. The slope of a line is also called the gradient. Now, what is a gradient? Now, gradient can also be defined as rise over run. Let me write it down. Rise over run. Alright. So what do you mean by rise over run? Now, assuming this is a slope and you're walking from here to here, you have risen by how much? 0.8. And how much have you moved horizontally? 2. Alright. Let's say this is 0.8 meter and 2 meter. Alright. So your gradient, let's say the gradient of this slope is, we call it M2. M2 will be equals to 0.8 over 2. 0.8 over 2. And look at it, this is actually tangent theta. Now the slope is also equals to the tangent of this angle. Now let's say this is the line. This is the line. Now the angle will be defined by this angle theta mixed with the horizontal ground, the right hand side of it. Assuming you draw a cross over here. You draw a cross and this will then be the origin. Now so it will be the line that mixed with the positive x-axis, alright, and your angle has to be measured in this way, alright, this direction. This is counterclockwise direction. Okay, now let's say there's another slope is sloping this way. Now, so what is the gradient of this line? Alright, and we call this gradient M, let's say. Alright, let's call this M1. Okay, so what is the gradient of M1? Now, gradient of M1 will be tangent beta. Now, what is tangent beta? Now, I already explained to you under the chapter on trigonometric function that tangent beta is equals to minus tangent alpha. Okay, what is tangent alpha? Tangent alpha is 1.6 over 2, so it's minus 1.6 over 2. Okay, that is your gradient for this line over here. Now let's do a more generalized line. Let's say this line has a coordinate of x1, y1 and this is x2, y2. Now what is the rise over here? The rise will be given by y2 minus y1. Then the run will be x2 minus x1. So your gradient here will be your rise over your run. So y2 minus y1 over x2 minus x1. Now you may be asking yourself, so you are given a pair of coordinates, which one must I use it as x1 and which one must I use it as x2? Alright, it doesn't really matter. Now let me show you. Now let's say I factorize, I take out a minus 1 from the numerator and denominator. So it will be minus y1 minus y2 over x1 minus x2. Okay. Now the negative can cancel off each other, the negative 1. So you find that this is equals to this is also equals to y1 minus y2 over x1 minus x2. All right. Now, let's bring your attention to this diagram over here. Now, if this is a horizontal line, what is the gradient of this line? Now, the gradient of this line is 0. Why is this 0? Now, you look at it, the gradient is y1 minus y. Is the difference in y over difference in x. The difference in y is the rise. All right. It has the same y coordinate if it is the horizontal line. So it will be 0 over x1 minus x2. So that's why the gradient is 0. Now, let's say the gradient of this is 1. Now, this is steeper. So this will be greater than 1. All right. So as it goes this way, it's getting, the gradient is getting bigger and bigger and bigger. Okay. Now, let's say this, let me call it gradient 2. All right. Of course, not necessarily 2, it could be 3.5, could be, but it must be greater. If this is 1, then this has to be greater than 1. And here will be less than 1. Now, what happens if it comes down this way, or rather the line is going this way? Now, then it has a negative gradient, just like this example. Now, let's say this is minus 1.5. Then this is steeper. So this one will be larger in terms of the magnitude. So this will be, example will be perhaps minus 2.5. Now, how about a vertical line? Now, we come back to this formula. For vertical line, the x coordinate is the same. All right, the x coordinate is the same. So is the difference in y divided by 0. Now, something divided by 0, the answer is undefined. All right, so for a vertical line, the gradient is undefined. Okay. We shall now look into the relationship of the gradient of two lines that are perpendicular to each other. Let's call this line L1 and this one as L2. Now, what is the gradient of L1? All right, let's call it gradient of L1 as M L1 will be given as tangent theta 1, and that is B over A, because they are perpendicular to each other. So this is 90 degrees. Now, if this is 90 degrees, tangent theta 1 will be B over A, opposite over adjacent. So you get B over A. Now, let's find the gradient of L2. Let's call the gradient of L2 M L2. Now, this is given by tangent theta 2. Tangent theta 2. Now, what is tangent theta 2? All right. Now, this angle here is 180 minus theta 2. All right. So, tangent theta 2 is given by minus tangent 180 minus theta 2. Okay. Now, what is tangent 180 minus theta 2? Is A over B. So that will be equals to minus A over B. Okay. Now, if you use m1 times ml, the gradient of line 1 times the gradient of line 2, what will you get? Okay, now let us write over here. ml1 times ml2, you get b over a multiply by minus a over b, and you got minus 1. Now this relationship is very important. Alright, it's something that you will always make use of. They like to test you on this property. That means if you know the gradient of one of the line, the gradient of the other line that is perpendicular to it is just the negative reciprocal of it. Now what do I mean by that? Let's say the gradient of this line is, the red line is 3 over 4. Alright, the one in red is 3 over 4. So the one in green will be minus 4 over 3. So 3 over 4, you just flip it, becomes 4 over 3, and you just change the sign. Alright, from positive to negative. Now I give you another example. If the gradient of the green line is minus 2, alright, minus 2. Minus 2 is minus 2 over 1. Now, so the gradient of the red line is the negative reciprocal. So you flip the minus 2, it will become 1 over minus 2. Now, you change the sign. So it becomes half. Okay? Now, we will then move on to an example. In this example, you're asked to find the coordinates of AB. But you're given 3 lines. L1 and L2 are parallel to each other. And L3 is perpendicular to L2. Now, if L1 and L2 are parallel and L3 is perpendicular to L2, that means L3 is also perpendicular to L1. Alright. Now let's write the coordinates of these 2 points first. Now this is y is 0, so this is so x is 0. So 0 minus 0.5. Okay. Now what's the coordinates of this point? This is 1, 0. How about this? This is 3.5, 0. Okay. Now, if these 2 lines are parallel, L1 and L2, that means they have the same gradient. Alright? So you have m of L1 will be equals to m of L2. Now, what is the gradient of L1? Alright? Now, you use the formula y2 minus y1, no, y2 minus y1 over x2 minus x1. So, you use 0 minus 0.5. So, 0 plus 0.5. Okay? So, 1 minus 0. So, this is half over 1. So, the answer is half. Okay? Now, what is the gradient of L2? L2 will have the same gradient as L1. So, you have 0 minus b, 0 minus b, 3.5 minus a over 3.5 minus a, and that is equals to half. Okay, and then you do a cross multiply, so you will have 3.5 minus A will be equals to minus 2B. Let's call this equation 1. Now, this is perpendicular to L1 and L2. L3 is perpendicular to L1 and L2. Now, what is the gradient of L3? Now, you can find the gradient of L3 by using these 2 points over here. Okay, so gradient of L3, so I have ML3 will be equals to B minus 0 over A minus 1. Now, what is the gradient of L1 or and L2? They are both half, alright? Now, since this is perpendicular to L1 and L2, so the gradient of L3 is the negative reciprocal of L1. So you need to change the sign and you flip. So it's a positive, now becomes a negative. Okay? Now you can do a cross multiply. So you got B is equals to two minus 2A. Okay? Now you can try to solve the simultaneous equation of 1 and 2. Alright? Now I leave that to you, alright? And you will find that A is equals to 1.5 and B is equals to minus 1. Alright? Now we have come to the end of the video. Now if you like our video, please press the subscribe button. Have a nice day. Thank you.